This conference will now be recorded.
Good evening, everyone, and good morning as per your time zone. Okay, so this is Roshan. I am here with one of the workshop on microservices, Docker, and containers. So let's get started. Okay, so we'll understand about these microservices, Docker, and containers, and what are these, and how to, what's the importance of these uh, microservices, Docker, and containers in performance testing in engineering world, and how to take up about going about how to go about these things, and what's the next steps after that. So we'll be covering about these topics today. Okay. So this is something about me. I have around 14 years of experience, 14 to 15 years of experience in IT. Mostly worked into performance engineering, Java and Python development. On the cloud side, I'm architect associate, and I have been doing automation as well using various languages: Java, Python, JavaScript, and PL/SQL, shell scripting, Selenium. So I'm currently working as a principal performance engineer and SRE in one of the organizations. Okay, so this will be the agenda of our discussion today. So to understand microservices, we need to understand what the monolith mean. And if you understand what's the monolith, we can understand better what's the microservices. We'll understand the advantages and disadvantages of monolith applications. Microservices overview, we'll understand. Let me just put a layer. We'll understand the microservice architecture, the characteristic of microservice architecture, and how does it differ from monolith, and what's the advantages, again the disadvantages of microservices, and why we'll understand why the industry is moving, IT industry, IT development is moving towards microservices. That's the very take home message from this workshop. The runtime environment. Okay, fine. We understood after understanding microservices, advantages, disadvantages, architecture. Where do we exactly run these microservices? What's the runtime environment for microservices? We'll understand that, and we'll introduce a container engine. We'll understand what does this container engine mean actually, and we'll talk about Docker as the container engine. So this will be a very any session from very scratch. This is very much applicable to someone who is very new to this microservices, container engine, Docker, all these things. Okay, so it is very scratch session. You will understand. It's very scratch. Okay, so we don't have any prerequisite required to attend this session. So just be with me for some time, and you will understand all these things. If I'm just reading through the agenda, so it may be overwhelming, but don't worry. So we'll understand this container engine. What do we mean by container engine? And Docker happens to be one of the popular container engine. We'll talk about that. How do we install Docker, and what's the importance of Docker? So we'll understand that, and we'll understand the runtime environment for microservices, and then we'll introduce containers. How do we create containers? Basically, we host microservices in containers. We'll understand those things, about these things in maybe in 1.5 hours. We'll try to cover as much as possible. So I would request everyone to have questions, and to put in the chat if they have questions. And I have the chat window open in front of me in my second screen. So as and when I'll get some time, I'll look into your question, and I'll address them. So thank you. Okay, so let's understand what this monolith application mean. So we are currently working in monolith mostly. If you look at uh, the IT evolution over the period of time. So when I say monolith, so all our application logic, the application is, they are hosted on one application server. We have basically, it's a 3-tier application. Okay, and we have presentation layer, that's called the web server, and we have application server, and we have data layer, the database. And when we have all the business logic, if all the business logic resides in the application layer, uh, all to application server, basically we deploy our application on the application server. It could be Tomcat or WebLogic or WebSphere, JBoss. And if we deploy as a WAR file, right, we do that, or any or ER file, and we host everything, all our code all our logic. So let's say I've taken the example of bookstore app where I'm dealing with 4 modules. It's accounts, shippings, payments, inventory. It could be any other application like Flipkart. Just imagine some modules of the application. And when all the modules are in one application server residing, that's the monolith architecture, we call it monolith application, where if you have, let's say, functions defined for these modules, these functions are getting called everywhere and anywhere. So let's say I'm defining F1 to F10. There are 10 functions or methods defined in this accounts module. And I have few functions F11 to F20, let's say, a few functions like logic, right? Uh, and I can call any function from F1 to F10 in shipping module. I am free to call any function. So if there is such kind of dependency between the logic, between the modules, I can call any function, I can use any function anywhere, and I can call any function anywhere and everywhere across all the modules. Those kind of setup we call monolith application. And where the modules are tightly coupled. Here, these modules are tightly coupled, we call it. Okay, and that's the monolith application. What we mean by that? That's the basically monolith application. So I'm focusing on the application layer here. So this application has got 4 modules as I'm seeing, and when I'm able to call the functions, use the functions, reuse the functions which I'm writing for one of the modules for other modules anywhere and everywhere, and that kind of setup is called monolith applications. Okay, uh, it has some advantages, but a lot more disadvantages, I would say, because when I am calling, obviously, if I can reuse the code, these are this is the famous, the best advantage would be that I just need to write with the code logic one, and I can reuse the code. That's perfectly good. That's a good merit. But what if one of the modules goes down? Let's say accounts has got some bug. F1 to F10 I have defined, and let's say accounts model has got some bug in it in one of the logic. Then there are high probability, high chance that my entire application can come to a halt. It will be, the entire application could go down. There's a high probability of doing that because I'm calling the functions anywhere and everywhere. There is a high dependency across these modules. So that's the threat on my application availability, right? My application will not be available even if there is a issue with one of the modules, small bug in one of the modules also. Consider like Ola app, okay, or Uber app or Swiggy app that we use, right? There are multiple application, multiple sub applications, there are multiple functionalities there. Let's say one of the functionality happens to be notification, and other functionality, the main functionality like booking a cab or ordering a food from Swiggy app. If notifications, let's say functionality is not working, is it good that I'm not able to order a food or book a cab? No, right? Those kind of applications is not reliable. Those are, and no one would like to use those kind of applications. But that happens in case of monolith applications, because if you have a monolith application where you're calling the functions anywhere, writing one place and calling the function anywhere and everywhere, there is a high dependency that even if one of the module goes down for any region, it could be a threat to other applications as well, and my entire application can come to a halt. That's the biggest demerit of such a monolith applications, and that's what I have been showing here. Though it has some advantages, I can reuse the code. It's a single unit of deployment. I can deploy everything at one place, right? In one shot, I can build all my code at once. Uh, you know the software development, right? When a developer writes the code, he has to build the code, right? And the build and the code has to get deployed, right? So because it's a one big code base I can build entire code base at once, and I can deploy at once. So that's the merit, that's considered to be a merit. And it has some IDE support, like let's say if I'm working on Java, I have the IDE support like, yeah, your Eclipse, right? And where I can develop my entire application, entire functionality in one language. I can do that. So that's a disadvantages. But considering the advantages, you have a lot more disadvantages, as I was mentioning some time back. In the case of monolith applications, okay, it could be often very large. Yes, technology dependency. Yes, if let's say when I started writing my code, let's say because I have to start with somewhere. Let's say I started with writing accounts code for the accounts module. I started with, let's say, Java, writing my accounts, all those logic in Java language using Eclipse, let's say. And let's say my business is ramping up. I'm adding up more functionalities, let's like payments, inventory, or shipping. I don't have any other option but to choose Java and continue. I do not have that flexibility that I can use any other language or technology for other modules in for my application. I have to stick with the same language where I started with. So that's one of the demerits, and we'll understand that why it's considered to be demerit, because there are new technologies coming in. Now the codes which have been written earlier in C++, now they are being written in Java, and that will be the future again, right? If a new technology, new language comes in, more efficient, uh, again, we would try to migrate our code to that particular technology or language, right? But that's not basically, and if a new features comes in, I cannot adopt that new technology. I have to stick with the initial decision, whatever I have selected initially. So that's one of the demerits. It's not good, right? Implemented using single development stack, as I was mentioning, right? So once you have selected a development stack, you have to continue your ramping up your other modules using the same development stack. Frequent deployments are not practical. Yes, obviously, right? We work in agile, right? And you must be, if most of us are working agile, and you must notice that there are quarterly releases only happens, right? For small bug fixes, we wait for a major quarterly release, and then only we deploy everything all at once with that quarterly sprint, and then we get the users get the code in production, right? Because it's such a huge application, such a monolith application, so much code is there. It's not likely that we can have a frequent deployment. And we'll understand this context better when we'll talk about microservices, because these are the disadvantages, whatever that disadvantage of monolith, we are trying to solve this problem, all these problems using microservices. And we'll understand that all these demerits would be the microservices is the solution for all these demerits of the monolith applications. That's the path we are going. Okay, and need to scale the entire application stack. Yes, let's say again one of the major drawback here. Let's say I am having Flipkart. Let's say there's something called search logic. Let's say one of the logic search, right, where I'm clicking the invoking the search functionality. Let's say I know that in retail applications like Flipkart, Walmart, those kind of applications, the search functionality would be invoked more often than any other functionality, any other logic. So there are more user hits to those kind of functionality, right? Obviously, with users tend to search more, right? Search for this product, that product. If I want to scale up just the search functionality, let's say, I cannot do that specifically. If there is a requirement, let's say more users come in, there more load. Okay, I do not have the flexibility to just upgrade the capacity or the scale out the capacity of only one module. I cannot do that. In the case of monolith, I have to increase if there is such a requirement. Let's say I'm doing a load test in Jmeter or LoadRunner, and I'm observing that one of the transactions is getting. I did a workload modeling, and I understood that there is one transaction, one or script, one flow, which is having a higher hits of the users, and we need and let's say we understood that it's a resource constraint. We don't have enough capacity on the server. Okay, and this could be because of the only one transaction, only one use case, and I just want to scale out the resource only for that use case. I do not have this flexibility in the case of monolith applications. If there is such a requirement that, say, one of the modules needs more capacity, server capacity, hardware capacity, they need more capacity, I cannot specifically mention to just I cannot assign a dedicated resource only one module, right? I have to increase the entire application server. That's the demerit, right? Because unnecessarily other modules are running fine. I do not have any issues with any other applications, any other transactions. I just have the concern with only one transaction, only one type of use case. And because of that, I have to increase the entire capacity. That's a waste of resource. That's not good, right? And this is what happens in case of monolith applications, right? And we're trying to solve these problems, all these problems by using microservices. Okay, I hope everyone understood the disadvantages of monolith applications. If you have any questions, you can feel free to put your questions in the chat. Okay. Okay, and let's understand this. So we are trying to solve these problems of monolith applications architecture using microservices. So what are these microservices? Basically, I am trying to use the same functionality, same modules. In this diagram, I showed you that I'm having a bookstore application and I have 4 modules of these 4 functionalities. Call it module A, module B, module C, module D, ABCD. And these modules are tightly coupled. I am calling the functions defining in one module anywhere and everywhere. There is a high dependency in this kind of architecture. Let's split this. Let's split this and make it separate entity. Account separate, payment separate, inventory separate, and shipping separate. Just divide this monolith into microservices. Make it 4 microservices. And I do not want any module code particularly. I don't want the accounts. If I'm executing accounts module and I'm writing code for it, logic for it, I don't want any function to be called. I don't want to call any function which is being written for payments, inventory, shipping. I want to make this guy independent. Every microservice is independent. That's the target. Because of that only I will achieve high availability. My notifications of, I was taking the example of this Swiggy and Ola. If notifications module functionality is not working, it doesn't mean I cannot order a food or I cannot book a cab. It should be independent. The reason why I'm able to book a cab or order a food, because those 2 modules are independent. One module is not impacting the functionality of the other module. And the reason, because these are 2 different microservices. When I say microservices, that's what I want you to realize, that the modules are independent. Okay, the functions, whatever I am writing the functions for the accounts, I'm not calling those functions anywhere in other modules. That's what I want you to write pictorially. Let me just try to make this explanation better, crisp. What I'm telling, let's say if I have this application, let's say a bigger application, I have it, and I'm dividing it into various, let's say, modules. Let's say this is my module A, this is my module B. Just imagine like same way, okay? Let's say this is my module B, this is my module C, this is my module D, whatever. Okay, just let's say 4 different functionalities. Whatever functions I'm writing here, let's say, because to execute this, I need some functions, right? I need some logic so that let's say this F9 to F10, whatever I'm using here. I'm using these logic, these functions, these methods for this module. And let's say I'm writing some others module F11 to F12, whatever goes on till F20, whatever F is not required to be same, let's say F25, whatever. So whatever functions I'm defining for module A, I'm not going to call these functions anywhere. All my modules are independent. There could be a code duplication. I may need to, because there could be a case that I may need to write something duplicate code. I'm not going to call it. If there is such a thing where I need to write, like let's say I'm typing in another module F26, F27, and there is a need that I need to call F3 of module 1. I cannot call that because that will be a dependency. I may have to duplicate the code. I may have to write this code again. I will write it. Okay. I will write 28, a different function, which is like a similar to F3. There could be a case, something of that sort. But I will achieve independence, right? So my microservices will be independent because I'm not calling the functions. And if let's say my module C is down, third module is down, it is not going to impact other modules. And let's say because see, the point is to decide how many microservices you would require. So if it's a new development, so whatever the new development is happening right now, they are all into microservices because they all understand the importance of microservices. The older development, which is already the application is monolith, they are also trying to migrate to microservices, and they're trying to think how can they split the same functionality into various microservices. When they are deciding this, they also look at if we need to create different microservices on what criteria. If they think, let's say I'm coming with this module 4, let's say this is my module 4, and I do see that this module 4 has a similar functionality than module 1. Let's say 50 to 60% of the code is same. Then why to have these two modules separate? You can club it together. Module 1 and module 4, you can club it. If there is a lot more code duplicacy is there, we can club these two. Microservices is just a subset of your application. You can club it. Clubbing means those I can call within one microservices. I can call F1 anywhere, okay, within one microservices. So there is no point in that. There is no denying. There is no problem with that calling the functions. I'm just trying to make it separate so that my application availability should not suffer, even if one module is down. That's what, and this decision takes place at the very high level, highest level of your organization, when the architects sit together and they decide how many microservices we're planning and how we're planning. So a lot more discussion happens there. That's a separate issue. But why are we doing this microservices? To make my application highly available. I do not want my application to be down by only one. I don't want to have to keep it down just because of one small bug in one of the modules. I don't want the entire application to be down. It's a very huge threat to my application availability, and that's not a good thing. So because of that, I'm talking about microservices. And when I just make it these modules separate, independent entity, I can achieve a high availability and a lot more other features. I can have a lot more other advantages. We'll go over that. So what is microservices? So if you want to design an application that is uh, multi-language, yes, I will talk about that. When I was explaining this, when I'm converting into microservices, it's not a requirement that all my modules are written in the same language, same technology. There is no such, I would say, commitment or no such limitation. Okay, this module could be written in Java. This could be in Node.js. My other module could be in Node.js. My third module could be in Python. My fourth model could be in Golang. There is such a flexibility you get it with microservices, and if there is a requirement to interact with each other, these modules, how can they interact with each other? They can interact using REST API. They have this API exposed, and they can call that API, and they can communicate with each other. But the development wise, because they are not calling the functions uh, between two microservices, they are free to use their own technology, their own language. It has a greater flexibility than monolith applications. Yeah, within one microservices, I have to be consistent. I have to use the same technology, same language within one. But I'm free to use. This could be a search functionality. This could be my other functionality. This could be my other functionality within the same application. I'm talking about different modules, and these modules could be developed in different technologies and language. That's the merit I'm talking about. So if you want to design an application that is multi-language, easily scalable, easy to maintain and deploy, highly available. That's the key word, highly available. It's not going down that easily. And minimize failures. And then use the microservices architecture to design and deploy a cloud application. If you have such a, these are the merits, microservices definition or merits you can say. So in a microservice architecture, each microservices owns a simple task. As I was explaining, each microservices is just a subset of your bigger application, one module, nothing else, and communicates with the clients or with other microservices by using lightweight communication mechanism as RESTful API, as I was mentioning about. So just to sum it up, creating smaller and multiple component services which are built to handle a very specific concern, as simple as that, called microservices. And multiple services make up this application. When you combine all these microservices, you are defining microservices 1, microservices 2, microservices 3, microservices 4, or you can call it module. When you combine, they make up a one big application. Okay, that's the definition part. I hope everyone is with me, and we are going smooth. Can I get some acknowledgement from you guys? Are we doing good?
Yes. Yeah.
Okay, perfect. Thank you. Look at this architecture. So coming to the architecture, you can understand that this is the API gateway, one of the cloud service. With every cloud service provider, either AWS or Azure or GCP, we have this API gateway. Okay, and we create our API. If you want to just see, I must be having AWS account open. Okay, so if this is the AWS account, I have this, and if you look at this API gateway, as every cloud service provider have this API gateway. So basically, we create API here, and similar kind of service exists in Azure as well as GCP. Okay, so and we can create basically the APIs. Okay, so development activity. So create, maintenance, secure APIs. Okay, so let's say you have this API gateway and you have multiple APIs, and you can have different microservices. Microservices 1 is written in Java, microservices 2 written in Python, microservices 3 written in Go language. The microservices 2, this microservices 1, interacting with, they get this information from Microsoft, they are interacting with microservices 2 as well as 3. Microservices 2 is getting information from NoSQL database, and microservices 3 is getting information from SQL database. You can design one of the architecture. I'm just showing you. There could be many more microservices. Okay, so this is such a flexibility. If you look in the architecture you get when you have microservices in place instead of monolith. In monolith, we don't have such a flexibility. I have to stick with one technology, whatever I have selected, Node.js or Java or Python, whatever, anyone. I do not have that flexibility. Even if like future my business is expanding, new technology, much more efficient technology has come up, and I want to incorporate that as part of the new business, new module in my application, I can use that very much. I can use the new technology, new language, and I can integrate as the microservices for there. I have that option with me. Okay, so architecture of an application. So one simple architecture I'm just showing you. It's not a generic architecture. It's for one of the application I'm just showing you how microservices are basically architected. It's not the architecture. Okay? It's one of the architecture of any one application. Uh, so the architecture of an application that consists of multiple microservices, as simple as that. Microservices enable you to design your application as a collection of loosely coupled services. I was using the word tightly coupled services in the case of monolith, where my modules are tightly coupled with each other. I'm calling the functions anywhere and everywhere. Writing in one module, but I'm calling it anywhere and everywhere. That's the tightly coupled example. Okay, in the case of monolith. But in the case of microservices, the microservices are loosely coupled. They are coupled through REST API. Okay, but they are not dependent at the code level. They are independent at the code level, and that is what very much reliable for the application availability, and that's what playing the biggest role there in keeping my application available. And I will talk about much more advantages of microservices. There are a lot more microservices. Microservices follow the say nothing model, as I was mentioning, no code dependency, and run as a stateless processes. So if it runs as a stateless process, you can scale it very higher. That's the advantages of a stateless processes. You can scale it well. And that's why if you look at the new microservice architecture, we are getting performance issues of a different kind. Half of the performance issues got resolved by just implementing the architecture, just by going monolith to microservices. Half or even more, 60 to 70% of the performance issues got vanished by just switching my architecture from monolith to microservices. We used to get a lot of different kinds of performance issues, but now we also get a performance issue, but a different kind, not on the way of scaling those part. Okay, so it can scale a lot, stateless processes. This approach makes it easier to scale. Stateless, you can just Google it. Okay, stateless application. I'll just give a brief about that. Stateless applications can scale a lot because it doesn't need to store information. Okay, it can grow a lot. It can scale a lot. Just Google it: stateless and stateful application. This is the property of the application that you develop. You do not need to store it's kind of a cookies or session IDs for the stateless application. It can scale a lot, stateless applications. Okay, so when I say microservices, these two words should come: autonomous and specialized. These two words should come. Autonomous. The modules are the microservices are autonomous. They are independent and they are designed for one specialized purpose. If I am, let's say, migrating from monolith to microservices, and I'm dividing my monolith application to microservices, all my microservices will be designed for one specialized purpose, use case. It will be a sub module of a bigger application. It will be one of the sub application, and it will be specialized. So here in this diagram, I'm showing you, I have accounts, I have shipping, I have payments, I have inventory, but I do not have dotted line in these between. That's the difference you should note here. The way it is like this, these are tightly coupled. I'm showing you the bigger box here. They are tightly coupled. They are one unit here, and that's the problem. That's the problem. But in the case of microservices, they are not one unit. They are an autonomous and a specialized unit which interact with each other through lightweight RESTful API. And when you make up everything together, and when you deploy that, we'll talk about runtime environment. When you deploy that, it becomes one application, highly available, highly scalable application. That's the microservices characteristic. If you look at the advantages, there are huge advantages, huge. Flexible scaling. If you want to just scale, let's say accounts, for example, I was giving that example of Flipkart search, right? If you want to, for example, let's say accounts, if you want to just scale, if you want to have allocate more resource capacity for one of the microservices, you can do that. You do not need to scale the entire application server as you were doing in the case of monolith applications. You can scale for one microservices capacity. You can provide more capacity to be used by this microservice. You can assign that. There are ways. That's why we need container engine and container orchestration engine like Kubernetes. And that is why Kubernetes is the most popular tool, because that orchestrates everything. And container engine like Docker, because container engine will help you create containers. And these microservices, they are hosted in containers. Right. So I'm just giving you some of the ideas of where do we run these microservices. These microservices are run in Docker, container engine, and containers basically. And container engines helps you create containers. And these microservices will run in containers. Okay, and there are ways you can allocate resource, dedicated compute resource for your accounts module if there is a requirement. You do not need to scale up the entire application server. There is no such requirement. All are independent units. You can scale them independently as the need is. Okay, so it's a huge merit. It's a huge advantage. Flexible scaling. I will get to utilize my resource better. I will not have just resource unnecessary resource allocated just to handle one transaction. I will have to increase the entire application server. What that's not a good thing, right? Unutilized resource, there will be a lot. Easy deployment, yes. Less code, for per microservices. If you look at, obviously, because we deal with each microservices here separately, so obviously we deploy it separately as well. If there is a code change in the account module, only the account functionality, account functions would be built, not any other code would be built. That, because that's the developer do. Once they update something, once they fix the code or implement some functionality, they need to build the code, whether my code is getting built correctly or not, or it's breaking, right? So once the developer fixed this code of this account in this account module, he's not worried about other modules, so he can deploy the bugs immediately. And that's why we have this CI/CD pipeline, just to make the deployment swift. Once the developer checks in the code in some GitHub repository, my code will be, I want my code to be deployed in production as soon as possible. And that's why we create CI/CD pipeline with all the validations, with all the quality checks, like automation testing, performance testing, everything would be done automatically. And at end of it, when everything is successful, my code would be deployed in production. And that I can do with, if I have separate microservices only. It's not possible, it's not feasible, not efficient to do the same thing with monolith. I have to build the entire application code. Just to fix one thing in the accounts, I will have to build the entire code in the case of monolith. That's not feasible, that's not a good thing to do. I have just fixed for this accounts. I will take care, I will only deploy for the accounts. Okay, and the same thing for easy deployment, as I was mentioning, because we are dealing with each microservice separately. Technology freedom, obviously, right? I was explaining it. I can have different microservices and different technology. I have that freedom, which was not there in the case of monolith applications. I was missing on that. Right? A reusable code. Yes, I can reuse the code within one microservices. Within one. As I was explaining, within one microservices, I can reuse the functions anywhere and everywhere. I can call F1 anywhere in this module. I can call F2 anywhere in this module. But the only thing is that I should not call F1 anywhere else, because that will defeat the purpose of microservices. But within one microservices, I can reuse the code. Resilience, needless to say, right? If that's the purpose of microservices, if one of the microservices goes down, it is not going to bring down my entire application. My application will be highly resilient. For one issue, for one microservices, let's say it's not going is gone down, and there are ways to make sure that microservices, there are replicas of that microservices are also there. I'm telling resilience, this gives you high resilience microservice architecture, because I maintain replicas also of other different microservices. So even if one of the microservices goes down, let's say I have not maintained the replica, I just have only one. In that case also, my other functionality will still be operational. It's not like for one of the issue my application itself is down, I cannot log in. It's not that way. And there are other ways also to handle that kind of scenario. I have replicas, and that's why we deal with replica sets. In Kubernetes, we have concept of replica sets, and that is why we maintain multiple pods in the case of Kubernetes. And we'll talk about that in some other day. Okay, but this is a highly resilient application that you get using microservices. It's not like it doesn't have disadvantages. Okay, I would be wrong that I would say if only I have the merits. Yes, it has plethora of merits, there's no doubt. It has disadvantages, but it is not like it cannot be managed. Okay, all these disadvantages which I'm going to highlight about, talk about, it is not like that it cannot be handled. It can be handled as well. That's what I'm talking about. The disadvantages itself can be managed. You can handle them if you plan it properly. For example, spawning. Spawning, what do we call spawning? Let's say there could be a case you end up creating a lot more microservices. You are dividing your monolith application into microservices. You are trying to break it up. I just broke it up in just 5 or 6 or 7 microservices. It can be managed. If you break it a lot more at the granular level, hundred of microservices, it's very difficult to manage everything. That's the spawning. If you have a lot more microservices, it is a problem. So you need to be smart enough. So I told it can be managed. So you need to be smart enough to create microservices in such a way that it doesn't create a problem for you. It doesn't become a maintenance issue for you. So you should not break your monolith applications also, split your monolith application into a lot more granular level. You need to be smart enough in deciding uh, the number of microservices to replace your monolith applications. So it should not be that much. So it can be worked out, and people have been managing that. But this is the disadvantages. If you create a lot more microservices, if you keep on adding new features with every microservices, it will be a problem in maintenance. But you need to maintain it, right? Because every microservices is a part of your application. You need to assemble that together. You need to they need to be communicating with each other as well. The restful the restful API has to be exposed properly. So those are the things. Okay, if you should not, what the advice is, should not create much more. You should not split your monolith into granular level where it becomes a problem. So that's the point. Okay, I do not want that kind of problem. So Maintenance, again the same thing. If you have a lot more microservices, it can be a problem. So just be smart enough in designing, and this is done at the very high level as the organization. How many microservices can we club these two microservices together? If we have let's say, as I was talking about, right, if I have a code base, I'm coming up with this list M4, module 4 microservices, and I'm observing that my F1 to F10, F still I end up using the same functionality. Let's say F1, I had to use F1, and I'm calling this a separate slate 100, which is equal to F1. I'm writing another function F01, which is equal to F2. And let's say I'm also coming with F102, which is equal to F3, whatever. So basically, these are common, and 50 to 60% of the code is same. Why do you want a separate microservices? Just club it together. You need to be smart enough to do that. Okay, so that it doesn't become a bottleneck in maintaining your microservices. Okay, duplicate code. Yes, you have to write the duplicate code. If you are trying to split, if you're trying to make it independent, yes, you may have to write some duplication could be there. But again, I was mentioning, if the duplicacy is more than 10, if it is 10%, 20%, fine, that's fine. But if it is more than 40%, 50%, 60%, you need to decide, can you club this together and can have a one microservices? Will that be reliable? So the considering the high availability, resiliency in mind, you have to decide that. Can we club this together? Obviously, if the code base is 50%, 50%, 60% is same, why do you need two microservices? Club it together, right? You just need to add five more functions. That's it, and you can have one microservices combining of these two functionalities. Microservices are nothing but the sub application. Okay, it's just your application itself. So sub module of your application, as simple as that. So you can club this together. So you can also manage this duplication. It's not like you cannot manage. Network performance, yes, it's also a problem. Network performance, in cloud there's the concept of availability zone, data centers. Okay, if two microservices, okay, if this microservices module 1, let's say this is module 1, it is deployed in, let's say, in Europe data center. This is deployed in this is module 2, deployed in US data center. Obviously, there could be a problem of network latency. So you need to be smart enough to decide when you are deploying, because you can decide these things. Where do you want to host your microservice? Because you are creating the servers end of the day. So you do not want a network performance issues in the case of microservices. We'll talk about that more sometime when we talk about Kubernetes more, how things work in Kubernetes and how do we handle this network performance. So basically, to sum it up, just to make it simple, the distance should not be much between two servers. More the distance, more the latency, as simple as that. If one microservice is in Europe, other one in New Zealand, the distance is far, right? Distance is far. More the distance, more will be the latency. So you need to be smart enough in deploying your microservices in the servers relevant to the customer's requirement. If my customers are in US, more of the customers, then why would you need to have a server in Europe or New Zealand, right? Have the servers nearby them, the customers, and there are network performance you can avoid the network performance. So as I was mentioning, right, the issues are not such that you cannot manage. It can be managed as well if you plan it properly. Okay, so this is the microservices about I was talking about, and once we understood this microservices, we can easily differentiate that between monolith and microservices. So there should not be doubt which architecture is better. Okay, it has a lot more functionality. You can achieve highly availability, reliability, resilient application. You can scale as per the process level. It has a lot more functionality. You can have a comparison easily now. Okay, so I hope everyone is good till this point, because next we're gonna understand the next part. Where do we run these microservices? What's the runtime environment? Where does microservices run? And we're gonna understand that. Can we deploy microservices on single server? No, see, it depends. It depends. Okay. First of all, we need to understand where do we host these microservices. Okay. We host this in the containers, and we create containers on the servers. We'll understand that, Manish. You have asked a good question, but yet the discussion is yet to be completed, so that you can frame your question better later. But having said this, you can deploy your microservices in multiple servers. We deploy in multiple servers, right? For high availability. What if one of the server goes down? What if one of the server goes down? So I would deploy my microservices in multiple servers, right? Because if even if one of the server goes down, I will have my other server I will have my microservices there as well. I was talking about replica, right? I will create replica, and once we'll talk about Kubernetes and pods, you will understand this better. Let me just get started. Let me just continue with the runtime environment for microservices. We'll understand that. I'll take up one more question. What is that? Sri Vidya has asked how we can work on throttling when TPS is not met. Again, you need to get to the bottom of it, right, Sri Vidya. So why TPS is not met? What is the problem, right? What is the problem? Why you are not able to get the right TPS? Do we have issues on the resource constraint? Do we have resource contention, or you have application issue? So you need to narrow down. You need to narrow down your problem, and then only you can decide what needs to be done. Peter, if first F1 important services fail, how will you proceed to next? Right. If you have such a case, Peter, that I was talking about replica, right? See, in microservices world, I will not have, like in the case of, because we have worked on monolith, so our mind thinks that we just have one app, only one app server, only one web server, and only one database server. That's what we think. And when I'm explaining this microservices, everyone thinks that I have just the one microservices for each of the functionalities, each of the modules. It's not that case. I have replicas. I do have replicas for all the microservices I create, because I have the flexibility, because I can run microservices in containers, in pods, and I can create multiple replicas of those pods. Basically, to sum it up, I will not have just only one F1. I will not have this microservices with F1 to F10. I will not have just one microservices. I will have multiple such microservices in multiple servers, because end of the day, I have to make my application highly available, reliable, right? I cannot trust on only one instance. I will create another server as well. I will create another server. Just try to get this very simple thing. I'm just trying to explain in a simple way. I will have one more server. Okay, this is my server 2, and I will have the same module defined there as well. Module 1 I will have defined there as well, and these two servers will be load balanced. There will be a load balancer across these two servers. Okay, so even if one of the, let's say one of the uh, modules goes down in one of the server, I have other places as well, other module as well available in on another server, which can handle the request, which can take up the request and give a response. I hope you understood, Peter, right? Just to brief it up, we'll understand more about it once we understand how do we run these microservices. Things should get much more clearer, and what's the footprint of it. Peter, I hope you're good with the explanation right now. Yeah. Right, right. Thank you. Okay, we'll understand this now. Okay, how do we run this microservices? Okay, how do we run this? We have the option of running these microservices in physical servers, huge servers. We can run on the VMs as well. You know these things, right? We have earlier when we started with physical server. Virtualization came into picture. We use virtualization software, VMware software, a lot more other softwares as well. We installed the virtualization software on the physical server. We created VMs, so we can run these microservices at the VM level also, and at the physical server also, directly on the server. We can also run that. And we can run the microservices in containers as well. So there are three places I can run my microservices. I can run directly on the server, directly, no virtualization software, directly on the server. I can run this microservices on the microservices at the VM also, where I am using a virtualization software and I create VMs. Mostly we are doing this, right? You have VMs, right? You have a server for database, you have a server for application server, you have a server for web server. That's what most of us are doing, right? We are in the containerization phase. We are into the virtualization phase. Virtualization was the big leap. We were able to efficiently utilize the resource much in a much greater way. When virtualization came into picture, it was a very good thing which happened to the IT industry, virtualization. Now we are in the world of containerization. We are in the phase of containerization. Virtualization came. Virtualization came here. I'm talking about where we're creating the VMs. Now we are in the phase of containerization. Containerization, where we are creating containers on the VM. Understood that? We are creating containers on the VM, and we will run this microservices on the container. And that's how I will efficiently utilize the resource. You can ask this, why are we running microservices on containers? Why are we not running directly on the VMs? Yes, you can ask this question. Currently, if we are working in a three-tier application, right, we are using one server for app server, application server. Let's say if it's a three-tier application, one server for app server, another for web server, another for database server. We are using that, right? Three servers we are using. The idea is to containerize this, use container engine like Docker. Container engine like Docker. We will install this container engine here in one of the VMs, and then we can create multiple containers. So basically, by using containerization, I can have my application server, my web server, my database server in one server itself. I'm able to utilize the resource in a much more efficient way. Okay. I hope I'm just thinking. I think not everyone would have got this info, this last part, but I'm just going to repeat that. Okay. In the case of a three-tier application, let's say if you're working with three-tier application, consider just three servers here, 1, 2, 3 here. I'm just circling these three servers. I'm using one server for app server, one for web server, another for database server, right? Mostly we are using that, right? Monolith applications, we are doing that. Now, in the case of microservices, I'm talking about splitting your microservices, splitting your application logic into multiple sub modules and create microservices. Now, I'm talking about containerization. It's a different technology. Virtualization, you saw this. I was able to create VMs when I used a virtualization software. Now I'm going in one of the VM. So this is one of the VM. Okay, I'm going to show you.
Roshan, sorry to cut you out. This is
Sure,
Anand here. I'm dropping
sure,
off, but before I drop off, I have a quick question.
sure.
So, do we have any full course on this one, like, wherein I can enroll and then get complete understanding of, the whole thing?
Right, right, Anand. Yeah, we have a course and we are coming up also with a course. That course is called Cloud Performance Engineering in DevOps. I think that's the link. Yeah, that's the link. We are coming up with this course and we call it Cloud Performance Engineering in DevOps, where we go about learning about the cloud. If anyone is new to AWS, will understand because nowadays everyone uses cloud and we're going to take up AWS. So we talk about AWS cloud. We mostly, when we work with of containers, microservices, Docker, Kubernetes, we all work with Linux operating system. So we also take care of Linux. And there are other AWS services like ECS, Elastic Container Service, that again, which is a containerization engine, orchestration engine, ECS, and there are RDS, relational database services. So we're going to talk about a lot in this particular complete course: microservices, Docker, Kubernetes. We talk about EKS, Jenkins, and CI/CD pipeline. So we talk about everything here in this course, and it takes around 40 hours to complete this course. And we go about so you can just, I have all the syllabus here mentioned here with all the topics which I was talking about: cloud computing and Linux, all the topics that we cover. We have it, and we are going to start a new batch from this Tuesday, coming Tuesday. You can find this information in this link. This is the Tuesday, 7:30 a.m. to 8:30 a.m. So we're going to also organize few demo sessions for you to attend. So you can just go over this link and get this information, Anand. That's what I can suggest you the best. Yeah. So if anyone is looking for a complete course on this, you can go over this link and understand. Okay, thank you, Anand. So let me continue with the discussion. Okay, so right now when I'm talking about VM, okay, here. So VM, I create EC2 instance. This is the AWS management console, and where I end up creating instance. So if you look at, I have few VM here created, already created. This is one of the VMs I created from the last batch. So let me just start this VM. I'm going to show you how do we create containers and what do we mean by containers and containerization. Okay, I'm going to start this. Let me just connect to this guy. Okay, I hope everyone is following, right? Can I get some quick acknowledgement, please? Till this is coming up. Yeah.
Yes.
Yeah. Thank you. Okay, I'm going to this is one of the VM. Okay, this is the VM I'm talking about here. I was talking about virtualization. AWS uses a virtualization software which we cannot see, but we can create VMs. So I'm just logging into one of the VM here, and I'm going to demonstrate how do we create containers and host microservices. That's what I'm going to demonstrate. So this is one of the VM I'm going to log into. Let me just copy this public IP. I need this. Okay, let me open this. So I'm using a putty software. Let me make it better so that you guys can see this. Okay, so I hope everyone can see this. Okay, so this is the VM I just logged into, and this is a VM. Okay, if you want to uh, currently I'm logged in as the Ubuntu user. Quickly you can be a root user like this. And now I'm a root user. If you want to understand how much CPU I have on this guy, you can just type ls CPU. And currently I have just only one vCPU here. And how much RAM I have, you can just used. I'm just using a free tier account, so that's why I'm not having many more CPUs, and I'm also having just 1 GB of RAM. Okay, because I've used this free tier 1 GB of one CPU and 1 GB RAM. So that's my VM right now, and I need to come up. I need to install to create containers, basically to create containers on the VM. because that's how I'm going to utilize the resource better, because that's the difference between a VM and a container. From physical server to virtual to VMs, right? When we took this shift, migrated, we were able to earlier on the physical server from big box. Imagine a big box of multiple vCPU and multiple RAM. Okay, consider thousands GB of RAM and thousands of vCPUs. This is the physical server. Earlier, what we used to do, back in 1980s, I'm talking about 90s, 70s, when the software development evolved, we used to develop and deploy one tiny application, few KB application, and deploy one big physical server. So you can imagine how much resource we were wasting, how much. And for each of those tiny little application, we used to have one separate physical server. You can imagine how much resource we were wasting. When this virtualization came, what we did, we used the same physical server and split its compute hardware into 10 or 20 VMs. Now we could deploy 20 applications in those 20 microservices, in those 20 VMs. Each application used to host in one VM. I created 20 VMs from this physical server, and now I can deploy 20 such tiny little applications. 20. So it's a big improvement, right? With there, I was just hosting only one application in that physical box. Now I can host 20 such applications when I just used a virtualization software. And now we are in the phase of containerization, where I can create multiple containers and I can host multiple microservices in one VM itself. In one VM itself, I am further breaking down and I can create multiple containers. This is a VM, one VM I am logged into. I can create multiple containers inside this VM. And to do that, what we do, we need to have a container orchestration engine, container engine installed. Orchestration, we'll talk about that later. We need to have a container engine installed. Container engine which can help me create containers. And Docker happens to be the most popular container engine. So we're going to install Docker and then we can create containers. And by that, we can host multiple applications in one VM itself. So I'm able to utilize the resource better. I hope everyone is understanding what I mean. So in this diagram, I'm just showing you that this is a VM and a container differentiation. Okay. This is the left is the VM, where you have this infrastructure, the hardware. You are using a hypervisor software, right? This is a physical server. The one I was explaining about, the physical server, you install one hypervisor software, a virtualization software. Then you create multiple VMs. This is a VM A, VM B, VM C, 3 VMs. Each VM has one operating system. So app A happens to be my app server, let's say. App B is my web server. App C is my database server. And I need separate operating system for all those VMs. You can recall your own application, what you're using. You're using guest operating system, right? You must be using some Linux, mostly Linux and Windows, and for each of your VMs, right? Separate operating system for all your VMs. But now I'm talking about containerization. I'm talking about containers. Let's say that this is my one VM. I'm showing you one VM here, and I'm splitting that VM into multiple containers. Container A, container B, container C. In this VM, I needed 3 VMs to deploy my application: app server, web server, database server. Here in one VM itself, I can create 3 containers. I can have one container for app server, one container for web server, and one container for database server. Just imagine how much resource I'm able to utilize now. From physical server to VM from VM to containers. And if the motto is to utilize the hardware better, that will in turn will improve the cost. It will reduce the cost of your organization. It's a big thing, reducing the cost by using containerization technology. And that's why Docker is the most popular. And we host microservices on the containers, and we need container engine. So we're gonna understand container engine. We're gonna install a container engine. So in this example, what I'm showing you, I have a VM, I have an host operating system. So here I'm using a host operating system called Ubuntu. That's my operating system here. You can just type uname-a, you can understand that's the Ubuntu I'm dealing with. I have installed one operating system, Ubuntu here. You can install some other application also, Red Hat or anything, Amazon Linux 2, anything. So this happens to be Ubuntu right now, Linux. I'm using this. So this is my host operating system. What I need to create containers, I need to install a Docker on top of my operating system. Currently, do I have a Docker here? I do not have a Docker here. I did Docker version. I do not have a Docker here. So first I need to install Docker. First I need to install Docker, and then I can create containers. Container A, container B, container C. 3 containers, multiple containers. As per the resource, I am just using 1 vCPU, 1 GB RAM, and 8 GB disk. I have disk also 8 GB only. I don't have much disk as well. I'm using 8 GB disk. So I have 1 vCPU, 1 GB RAM, 8 GB disk. That's all. But I can still create multiple containers in this resource configuration. If you use more CPU, more RAM, more disk, you can use even more containers. So what you need to do, you need to install a container engine called Docker, and then you can create containers. So let's do that. Okay. To just install Docker, you can simply type this command apt install docker io. Let me before update this operating system. I always do that. First thing is to update the operating system you're working on. So you do Windows update, right? So I'm doing the same thing using apt update. Okay. And then I can just install apt install docker, and I can just install Docker like this. Yeah. So I'm installing Docker is the container engine. There are other container engines as well in the market, like Container D. We have Podman. Uh, we have other containers as well. We have Rocket. There are other container engine as well in the market, but Docker happens to be the most popular container engine. The idea is to install Docker and create containers. And to create containers, you do not need a separate operating system. That's the point. You do not need a separate operating system to create containers. You can have a container for app server, you can have a container B for web server, you can create container C as a database server, but you do not need a separate operating system, how it was the case with VMs. So you are not just doing you're not just improving on the cost at the infrastructure level, but also at the licensing level. Such a improvement. Okay. So I have installed Docker here. Let me just check once. Do I have installed Docker? Yes, I have installed Docker. Good. Now to create containers, what do we do? I can create containers now. Now I have a container installed. I can directly install container easily without any doubt. So I can have a web server as a container. Okay. So to do that, I can simply type docker run -it-d. I just need to, I can just do one thing. I can just check, do I have any images? I do not have any images right now. I can get the images from the Docker Hub. If I just type Docker Hub, Docker pull httpd, it is going to pull one image. This is a web server. Okay. HTTPD is the web server. It is just pulling this HTTPD image. This image has the web server microservices. Okay, web server. It's the real web server. I'm going to show you right now. Okay, and now you can simply run this. Right now I do not have any container running, Docker PS. I do not have any container running. What I can do, but I have the images now. If I type Docker images, I have one image. Just now I downloaded from the Docker Hub. There is a place called hub.docker.com. Here all those uh, you have images for, you get a lot of images, free images. You can also create your own image. Okay, by I can sign in also, but let me not sign in. You can have you can get an image for HTTPD. This is a web server. This is a web server, Apache web server. I just issued this command to pull this image. You can also get this for the application server like Tomcat. You have a Tomcat as well. This is one of the application server, that popular application server. So you also have image for a Tomcat. You can also install Tomcat as a container engine, like MySQL database. Also, you can find it, Mongo database. There are so many images out there. Okay, you can simply pull it and you can run those. Okay. I'm going to just show you as time we have got, just to show you that we can create containers. Okay, MongoDB as well. See MongoDB. So you can use this MongoDB. It's a database. So there are so many things you can get it. Okay, so let me just I have this image right now. Let me run this image. If I run this image, it becomes a container. Docker run -it-d, and you can just do a port mapping. You need to do a port mapping as well. 82 port, because this is the web server runs on port 80. You need to map it on the host. So 82 port of the host maps to 80 port of the container. Okay, because this is how it runs. Okay, if I just type, and you need to mention the image name. If I just issue this command, see, you got one container, Docker PS. So I just created one container. Okay, this is the container, and this is the web server running on port 82. I can prove it to you. If I go to this URL of this server URL is this. Okay, public IP is this. This is the public IP of this server, and if I use the same port which I have used, expose this 82 port. If I hit this enter, I'll get a web server. It's a web server. It's a web server, and you can go inside this web server as well. It's your, just now I installed this web server, and you can have your own customized application. It works is coming by default because that's the index.html page. You can go inside this container as well. You can execute this command, docker exec -it, and container. You can just type container, this container ID, and you can just type bin bash. You can go in, look at this. Okay, look at, I'm currently as the root user. I'm going inside the container, and notice something. Can you see I'm inside the container? I was inside the VM. That's my private IP, 172.30.116.611. That's my private IP, 172.36, and now I'm inside the container. I'm inside the web server. Okay, I can go and I can change. I can understand from where this page is coming up. I can go to htdocs. Okay, and this is where my index.html is. This is where my index.html is. And if I just show you, that's how it's coming. It works. Like, you can change this as well, and you can make your own web page. It's a web server. and that's why you're seeing here it works. I can come out of this exit app. Now I'm again back to this VM. You can use other you can use other you can install a Tomcat. You can have a Tomcat, and then you can deploy a WAR file or ER file. You can have a app server. You can also install a MySQL, and then let's say if you have Tomcat or any other, if you have, let's say, any other, I can use, let's say, Jmeter, right? You guys are using Jmeter. You have a container also for the Jmeter as well. Okay, let me just show you. You have got a container image of Jmeter as well. Try to understand the bigger picture. I'm just trying to show you that in a VM, I can create multiple containers. The thing which I was doing in one VM, I was just having one web server. That's all I was having, right? In three-tier application, in one VM, that's all I have, right? I have only one web server in one VM. But here, in one VM, I can create multiple containers. I can have one app server, I can have the web server, I can have the database server as well. I can have everything in just one VM. If I just type docker pull this guy here, this will install a Jmeter container, and I can launch Jmeter. So I can basically, I'm just trying to show you that I'm able to utilize the resource better. I can not just this, I can also install some other operating system as well. I can use docker pull Fedora as well, because this is the Ubuntu operating system. I can pull Fedora operating system as well, and I can go in, I can run the Fedora operating system, and I can go inside that and work on something else. I can deploy Java there, I can install Jenkins, I can run anything there. That's what I'm just trying to tell you right now. If I just run this command, docker run -it-d Fedora, let's say, this will create another container, docker ps. Look at that, I've got two containers now. And the last but not the least, if you need to understand the footprint of these containers, you can type docker stats as well. Docker stats. By using docker stats, you can understand how much CPU, how much memory you have. You can allocate a certain amount of CPU to, let's say, this web server. I have a web server, app server, database server. Let's say I have everything. I installed MySQL as well. I installed MySQL, I installed Tomcat, I have everything. Let's say I've installed Docker pull MySQL. I did. I can pull MySQL, I can run it. It will run as the database. Okay, I can have Tomcat as well as application server. And now let's say I have a full-fledged application and I want to allocate a certain amount of RAM, a memory, to any one process. This is nothing but a process. Okay, container are nothing but a process for the operating system. I can do that. I can configure, I can define, I can allocate a certain amount of CPU, certain amount of RAM to be used by only one container. I can do that in the case of container. So basically, I can do what I was talking about. I can do the flexible scaling. I can do the flexible scaling. That's how I can do. I do not need to increase the entire application server itself. I can at the container level, this is the property at the container level. And this container could, if I have this microservice, let's say this is currently a web server, I can do that at the container level. This benefit I have at the container level, that I can allocate CPU, a dedicated CPU, a dedicated RAM to a container, and that container can have my microservices. I can do a flexible scaling. That's the merit I get from microservices. And when you have a lot more microservices, we have a container orchestration engine like Kubernetes, where we can do a load balancing across multiple containers. We can auto scaling, we can configure auto scaling. If the more load comes in, create many more containers, auto scaling. We have a lot more features on Kubernetes, and that's why we deal with Kubernetes. And that's why Kubernetes is the most popular skill set right now. So we're gonna talk about Kubernetes some other day. Okay, that's the brief I wanted to cover on microservices, Docker, and containers. I hope you learned something today. If you have any question, feel free to ask. Are we good? Yeah. You have any questions? Okay, perfect. So thank you everyone for joining. If you are interested, you can join me again on Tuesday. You have the link with you. You can join me on Tuesday on the demo session, and we're going to talk more about this course if you're interested in that session. 10th August. If the participants are in US, you can contact 9th of August, 10 p.m. to 11 p.m. your time. If you're in India, 7:30 a.m. to 8:30 a.m. So thank you, everyone. We'll connect some other day. Yeah, thank you.
Hi Roshan, this is
Yeah,
Anusha. Just a small
sure.
question. I've heard something about like Kafka services and they're related to microservices. So,
Correct.
like, what is that service?
Kafka is a messaging
I mean,
service.
what is that?
Messaging. It's a part of the architecture where you need to trigger some sort of messaging service to your application server or to your any server. You use Kafka or MQ. You also have in the AWS MQ also. Amazon MQ you have. This is the one of the services in AWS out of the box feature. Fully managed open source message broker service. That's what we call it. So Kafka is a open source tool, and you have a similar service in Amazon as well, MQ, where you can use as a messaging. Yeah, that's the
Between like
definition.
what this service exactly does? Like it, like just like you said, these container, no, I don't know if I'm, yeah, these microservices, they communicate with each other using REST APIs.
REST
Is
API.
that
Yeah.
something like that? Is this something like that? Like, is it some kind of messaging or communication
No,
services
it's
between
not
two
necessary.
microservices?
If you're thinking as part of the REST API, you need something of Kafka. It's not. We're talking about two different things here. Kafka could be used
Okay.
for some other functionality to get your app architecture needs Kafka, messaging as you messaging broker unit as it tells message broker service. If you need that kind of a service, then you will have a Kafka created message broker in the cloud. To have a communication, it's a RESTful API. You have REST APIs, right? You can invoke something through REST API. You can call another microservices using REST API and they need to be exposed the REST API. And that's how they communicate. There could be a case that between those two microservices there is a Kafka also in place. So that's a different architecture we are talking about. And it's not like to communicate with two microservices to communicate, you need a Kafka always. It's not the case.
Okay. 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 Thank you.
Sure, sure. Okay, thank you everyone. So if you want to learn more about this and want to learn more about cloud performance engineering in cloud and getting much more exposure on these things, you can join me on Tuesday at this time. That's not what I wanted to cover. Yeah, thank you everyone for joining. We'll see you some other time. Thank you.
Thank you, sir. Thank